Let's do quick practice. So now we're multiplying or dividing, between expanded notation digit by digit. We want students to get used to one of these algorithms, so we're going to do them side by side. In math expressions, these are the two main ones for 6th grade. There was place value sections in 3rd, 4th, and 5th grade, but now students are expected to have a standard algorithm. Both expanded and digit by digit can be considered standard algorithms. So we're going to do a step to the left, then we'll show what that step looks like to the right, so that students continue get to see both of them and ultimately decide which one works for them. Notice we're not doing all of the math. We're not going through every single step. We're just doing what's the difficult part. And the difficult part is coming up with that estimated divisor and that very first number in the quotient. So I would say, class, read it with me. 2,269 divided by 31. Class, do I round up or do I round down? Think about it. Class, and the whole class would say round down. I can move my 30 now as my estimated divisor. If I don't like all of these boxes and moving them, you don't have to delete the boxes at the bottom, because as the teacher or as a student leader, they can tell the class if they're not correct. But at least the boxes that are covered still show the students what the question is, so the student leader can lead the class. If you don't like the boxes at the top, instead of deleting them, just have the student leader write this answers inside of the boxes if you're projecting this to a smartboard or to a whiteboard, or if you've printed the slide and put it underneath your document camera. What is our multiplier? Think about it. Now, students that understand the multiplier and have their basic multiplication facts should come up with the number 70, because 70 times 30 is going to give us 2,100, which is really close to 2,269. So I'm going to estimate 70 here. If students do not have their multiplication facts, then notice to the left I created a 2-column table, and this is a really simple scaffold just to have on the slide for students who are still trying to come up with what that answer would be. If I took out one group of 30 and I put a 1 here, I would just have 30, and 30 is nowhere close to 2,269. So taking it out by groups of 1, I only get all the way down to 300. So instead, I'm going to go into my tens column. If I put a 10 here and I took out 10 times 30, or 10 groups of 30, I would take out 300. Well, that's still not close to 2,269, but let's see how far I can get. I can take out 10, 20, 30, 40, 50, 60, 70, and I would not go to 80. Why would I not go to 80? Because 2,400 is more than 2,269. Notice that's in your questions over here. So friends, what's the multiplier? Class, and they would all say 70. If they didn't get it, 10, 20, 30, 40, 50, 60, 70. 70 times 30, class, 2,100. Now I'm going to do the real math over here. So we have 70 times 1, class, 70. 70 times 30, class, 2,100. 70 plus 2,100, class, and now they would see that our answer is 2,170. So on the left, 30 times 70 equaled 2,170. On the right, we didn't put 70, we just put 7 in the tens place. So 31 times 7 is 217. But we know that really it's 2,170, because really the 7 is a 70. Class, 70 times 30 equaled, or 70 times 31 was 2,170. Now let's subtract. If I subtract 2,260 or 2,170 from 2,269, I would get, everyone, 99. Class, what would I get if I subtracted 217? I would get 9. Now, I can bring down this next 9 for my next step. But notice that when I have to bring down, students are doing that as a procedure, but not necessarily because they remember that's how much is actually left over here. We've just taken out the zeros. That's the only step that we have skipped. So because we don't have a 0 there, we have to remember to go ahead and bring that 9 down anyway, because we're taking a shortcut. So the teacher could help explain some of those steps as we go, but ultimately the student leader would be able to just drive the ship and go all the way through this much of the problem. Notice we don't go any further in the problem. We're just practicing coming up with that rounded divisor with the first possible quotient, deciding if that was too high and it took us above what our number needed to be. So some of these questions you can ask at the end of that particular slide. Did our multiplier work? And the class should say yes, because our multiplier was 70 and our product was less than the total that we had. What would we do now? Class would say we would find the next multiplier. But you can see as I go to the next slide, I can just repeat this over and over and over again. I could insert a new table, so I have all my facts there if I need them, and I'm helping students to see that it really isn't 7, it is 7D in this case, right? It is really not 7, it's 7D. But what's the difference between the two equations? One uses zeros, one does not. By lesson 6, now we're reminding students what a unit fraction is, and unit means 1. A uni is 1. So if you're doing remote teaching, then you can have this slide already printed, and you can see that there's 6 student leaders that would technically come to the board, and they would have written a unit fraction, 6 of the student leaders. Then student leader number 1 would say, what's my fraction? The whole class would say, let's just say you wrote 1/9, 1/9. Second student leader, what's my fraction? So every one of the 6 student leaders would write their own unit fraction on the whiteboard. If you're doing it remotely, notice that this slide already has the denominators there for you. So you would just have one student leader come up and say, class, what is the unit fraction? And the class would say 1/9. What's the unit fraction? 1/12. What's the unit fraction? 1/2. What's the unit fraction? 1/3. So on and so forth, so that students have practice not only reading the fractions, but reminding themselves or being reminded that a unit fraction has a 1 in the numerator. You can choose to do it either way. By lesson 7, we're going to compare fractions with the same numerator. Class, compare the fractions. 1/7 compared to 1/6. I'm going to point to the smaller denominator, 6. The smaller the denominator means, and the whole class would say, the larger the parts. The numerators are the same, the denominators are different. So the smaller the numerator, the larger the parts. What is the comparison? And the whole class would say 1/7 is less than 1/6. Class, read it with me. 3/4 compares to 3/5. Are the numerators the same? Yes. Let's compare the denominators. 4 is the smaller the denominator. The smaller the denominator means, and the class would say, the larger the parts. What is the comparison? 3/4 is greater than 3/5 because fourths are larger than fifths. Read the comparison. 4/9 compared to 4/8. Are the numerators the same? Yes. 8 is the smaller denominator. The smaller the denominator, class, the larger the parts, which means the greater the fraction. Compare, 4/9 then is less than 4/8. Why? Because 9ths are smaller than 8ths. Class, let's keep going. Are the numerators the same? Yes. 1/5 compared to 1/8. 5 is the smaller denominator, which means the class would respond, the smaller the denominator, the larger the piece, which means the greater the fraction. What's the comparison? 1/5 is greater than 1/8. Why? Because fifths are greater than eighths. So you can see that students get a rhythm. They start to say all of these things. Okay, so we're literally saying this together. Class, compare. 5/7, this is the class, compared to 5/6. Student leader, are the numerators the same? Class, yes. 6, student leader, 6 is the smaller denominator. Class says, which means it is the larger the fraction. Class, what's the comparison? Class, 5/7 then is less than 5/6. Student leader, why? Class, because 7ths are less than 6ths. So you can start to see there's a rhythm there. You decide if you want that same prompt. You could even insert a text box here to have those same prompts that I just used if you prefer them. But the idea is that you have a rhythm and students can just say over and over and over again, essentially the exact same statements until they get all of these rehearsed. Notice in the notes it's going to say 3/6, 3/9, And so you'll be able to read in the slide notes here what lesson it goes for. So this slide is actually for lesson 3.7, then 3.8, then 3.9, then 3.10, and then by the time we get to 3.11, we change the quick practice once more. Then we get to lesson 11, and now we're repeating a quick practice that often happened in 5th grade to start to build some of this fluency. So we would say 1/5 of 7, and the class would say 1/5 times 7, which is the same as 7 divided by 5, which means divide 7 into 5 equal parts. 1/5 times 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 is the same as 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5, which equals 7/5. Okay, so the responses are here at the bottom. I'm going to show you a way that I modified this in 5th grade to show students what the visual was, because what we're doing is we're taking 1/5 of 1 and 1/5 of 1 and 1/5 of 1, and every time we take 1/5 of 1, we get 1/5. So we're showing students why 7 divided by 5 is just the same as 7/5. Here's an alternative slide that student leaders can use with students if they're not really understanding what we're doing. Boys and girls, read it with me. 1/5 of 7 is the same as, class, 1/5 times 7, which is the same as 7 divided by 5, which means divide 7 into 5 equal parts. Now, you can have them write that, or we could just say it, right? Divide 7 into 5 equal parts. Class, let's divide 7 into 5 equal parts. 5 equal parts means we're going to do 4 lines, which will give us fifths in each one of those 7 pieces. So you can see that I made little marks for them to just make this much easier, but we just want students to see that this is exactly what we're actually doing, is we're taking 7 and we're dividing every one into 5 pieces. Now we know that we have 1/5 that we have to take of 7. And 1/5 of 7 is the same as 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. That's 7. If I take 1/5 of 1, class, 1/5. And 1/5 of 1, class, 1/5. And 1/5 of 1, 1/5. And 1/5 of 1, 1/5. And we would continue to do that for the entire bar until we got 7 of those. So then students would say 1/5 plus 1/5 plus 1/5 plus 1/5, keep going, equals, class, 7/5. So you may only keep this visual for even the first problem to remind them this is exactly what we're doing. When we have 1/5 of 7, we're taking 1/5 of every one of those 7, because 7 is just 1 and 1 and 1 and 1 and 1 and 1, which is the same as saying 7 divided by 5, which is the same as 7/5. This is the visual representation and a reminder of the work we did in 5th grade to prepare them for the work that we're going to now do in 6th grade. By the time we get to lessons 14 and 15, we are comparing and operating with fractions. This is similar to what was done in 5th grade, and the entire purpose is to build automaticity with these fraction operations. So the student leader would ask each of the questions that are up here in the top box. What is a common denominator for 2/3 and 5/6? Think about it. Class, and the whole class should say 6 because we're looking for the most common denominator. Now when I delete this top box, notice that it deleted several other boxes that revealed other things. So we want to make sure that we ask this question, why 6? But I tend to either do that on the very first time we do the quick practice, so why 6? I know if I delete that, it gives us the answer, and we're looking for a student to be able to explain that. But then after this first slide, I will hold all those why questions, and at the end of this slide, I will say, turn and talk to a neighbor, tell them why we chose 6. Turn and talk to a neighbor, we'll do that into a turn and talk. Okay, so what is the equivalent fraction for 2/3? Class, what would I multiply 2/3 by to get 6? Think about it. Class, and the whole class should say 2/2. Friends, 2 times 2 equals what? Class, 4. What's my new equivalent fraction for 2/3? 4/6. What is the equivalent fraction for 5/6? Class, 5/6, right? Because we're just multiplying it by 1 because now 4/6 and 5/6 are compatible numbers. So now let's compare. Friends, 4/6 compared to 5/6. Think about it. Class, and the whole class should say less than. Read the comparison. 4/6 is less than 5/6. Let's find the sum. 4/6 plus 5/6 equals what, class? And they would say 9/6. Class, find the difference. 5/6 minus 4/6 equals, class, 1/6. Find the product. 2/3 times 5/6 equals, think about it. Waiting for responses, waiting for thumbs up. When everyone has a response, the whole class would say, or the student leader would say class, and the whole class would respond 10/18. 2/5 times, or 2 times 5 and 3 times 6. Class, what's my answer? 10/18. And they would just continue that going through everything. Now, if you don't want to move the boxes, you could just have these all and move them up like this. You can just hide the answers, right? So you decide how you want to do that, but the idea is that students would go through this entire process for every one of these slides, do the number of slides that you see for the lesson. So you can say that this is 314. So there's 2 slides for 314, 3 slides for 314, and then we get to lesson 315. We're just building automaticity with all of these different skills. In lesson 16, 17, and 18, we're doing the same thing we did in lessons 14 and 15, but now we're adding finding the quotient. So we're going to find the quotient and we're going to compare it to the product in these lessons. So if you go here, you can see that we have the start of this. What's the common denominator for 5/12 and 3/4? The class should say 12ths because they noticed that 12 is a common multiple of both 12 and 4. What is the equivalent fraction for 5/12? And class would say 5/12. What is the equivalent fraction for 3/4? Boys and girls, what would I multiply by? And the class would say 3/3, right? We would delete that. They would start to see all these pieces. So this is similar to what we just did, but then we get to, now let's compare. Let's find this sum. Let's find the difference. Let's find the product. 5/12 times 3/4. Now we're going to, so that's everything that we've been doing. Then when we get to this slide, we're just rehearsing now and helping students commit to memory why we're doing various steps. So this is using, the product side is using the knowledge of unit fractions times a fraction. So when we see 5/12 times 3/4, that's the same as 5 times what? And students should say 5 times 1/12 times 3/4 because 5/12 is 5 1/12. So 5/12 is the same as 5 groups of 1/12. So this equals 5 what? And we should say it equals 5 3/12 times 4. Why? Because a unit fraction times a fraction. So 1/12 times 3/4 is the same as 3/12 times 4. So what do we have now? Now we have 5 times 3/12 times 4. Why? Because it's a whole number times a fraction. And a whole number times a fraction means I'm going to multiply that whole number by the numerator, but my denominator is going to stay the same. So you choose how you're going to go through that. What I just did was I just went through the thought, the statements, and that's all our students would be doing together. So the student would say, read it with me, 5/12 times 3/4 equals 5 times what? Think about it. Class, and they'll start picking it up. 5 times 1/12 times 3/4. Why? Because it's 5 groups of 1/12. So notice I say why, that would be the student leader, or that would be the teacher. Then the class would say because 5 is 5 1/12, which is the same as 5 times what? And students would say 5 times 3/12 times 4. Why? Because we're taking a unit fraction times a fraction. Then we're going to do what? And students would say 5 times 3/12 times 4. Why? Because a whole number times a fraction means we're going to take that whole number times the numerator, and the denominator stays the same. So again, I'm just reading it as I go, and students are saying all of these pieces. I can even write 5 as 5/1. So we know we have 5 groups of this 3/12 times 4. So it's really 336. I have 5 groups of those, which means I'm going to have 15 of the 36. So change this language. Do on here what you feel like is the most helpful for your students to just refresh what it means to multiply with those unit fractions. From here, we're going to take the quotient on the right-hand side, and we're helping students to remember that we're looking for an unknown factor. So 5/12 divided by 3/4 equals unknown factor, which is the same as, okay, so everyone's reading this. So the student leader would say, read it with me. 5/12 divided by 3/4 equals unknown factor, which is the same as 5/12 equals 3/4 times unknown factor. Now, you may choose to draw an area model to the right for students who that just feels like gibberish. So we know that if I had 5/12 and I was dividing by 3/4, I'd be looking for the unknown factor. Or I can say that I know that it's 5/12 and I know that 3/4 times an unknown equals 5/12. So that visual of the area model could be really helpful if you drew that next door to these problems as students were explaining their thinking. So why is that? Because we know that the product equals a factor times a factor. What does the unknown factor have to be? So now we know we're looking for this unknown factor. And if I multiply by the reciprocal of 3/4, I get 4/3. The reason I would do that is because that's going to give me 1. Well, if 3/4 times 4/3 equals 1, what does the other part of the factor have to be? Class, 5/12, right? Because 5/12 has to equal 5/12, and 1 times 5/12 is 5/12. So this side of the equation has to be the same as this side of the equation. What does all of this mean? It means that when I am dividing 15/12 by 3/4, that I can just take the same factor, or the same dividend, 5/12, and I can multiply it by the reciprocal of 3/4, because that's what I ended up with anyway. So 5/12 divided by 3/4 is the same as 4/3 times 5/12. And this step proved that. Multiplying by the reciprocal helped us to get there. So your job now is to help students to see this and just to practice it over and over again and go through each one of those steps. Now, I might even have them do the simplifying process if they still don't understand what's happening here. So essentially, we're saying that this green space, right, is the unknown factor. And we know it's going to be a factor times a factor, which equals a product. So if I make up my own new unknown factor, I would put it as an equation of 4/3 times 5/12, because I know that these are going to cancel out to 1, which means that 5/12 gets to stay there, which really that means I could have just kept this entire equation and eliminated a step. So I knew that 5/12 divided by 3/4 was the same as this step, 4/3 times 5/12. You can do the simplifying though, and you could have students say, well, 5/12 divided by 3/4, I'm going to take that 5/12 and I'm going to simplify it. So I know that 5/12 is the same as multiplying to get the same number, 3/3, and multiplying by 4/4. And all of this is going to be divided by 3/4. So now I know that this is still the same as 5/12. But now I can do my division. I could have done 3 divided by 3. Let's write this again. We'll do it up here. So I have 5/12 divided by 3/4. But I want to simplify 5/12 because I can't just divide straight across. So 5/12, I'm going to unsimplify it, multiplied by 3/3, because that's the numerator, multiplied by 4/4, because that's going to help with my denominator, divided by 3/4. So now I can do 3 divided by 3, and we know that equals 1. And 4 divided by 4, and that equals 1. Let's see what's left over. What's left over is 5/12 times 4/3. That's what we did all the way down here, is essentially we found the reciprocal. Now, I'm not sure that I find that to be very quick for quick practice. So if you needed to modify this for quick practice, you could take the product and you could just have students go through it and say it with you as you or a student leader wrote it together. So we could do 5/12 times 3/4. And we could say that's the same as what? And class would say 5 groups of 1/12 multiplied by 3/4. That's equivalent to 5 times 3 of 12 times 4. Let's just go ahead and write that answer. 3/36. I know that that means I have 5 groups of 3/36. So really what I have is 5 times 3 over 36, because I have 5 groups of this fraction. The fraction size stayed the same. The number of parts that I have, or the number of parts I'm counting, it changed. I now have 5 groups of these 3/36. So I have, which equals 15/36. So you see, I walked through that process instead, and if I come up with a way to say it over and over again, then students really are just practicing saying it and practicing those steps. So let's look at how we might then do that for our division. So now if I say 5/12 divided by 3/4, I wonder if we just wrote it as we said it. We know that that equals an unknown factor. Let's write it the other way. 5/12 divided by 3/4 equals unknown factor, or unknown factor times factor equals the product, which means we have 3/4 times unknown factor equals 5/12. Let's do the area model. The area is 5/12. Unknown factor is 3/4. We're looking for the unknown factor. Let's write 2 equations. 5/12 divided by 3/4 equals unknown factor, or 3/4 times unknown factor equals 5/12. Let's find this unknown factor. So what would that unknown factor be? Well, if I wanted to make this a 1, I know that I could do 3/4 times, and I'm going to multiply by its reciprocal, because that's going to give me 1. But then if this gives me 1, this side of the equation no longer equals 5/12. That just equals 1. So therefore, I'm going to rewrite this as 3/4 times the reciprocal times 5/12, so that both sides of the equation are now balanced. Let's take a look. 3/4 times 4/3, those balance out. That equals 12/12. That's just 1. Now 1 times 5/12, that equals 5/12, which is the same as 5/12. So I know that this works. So now I can just take this new unknown factor, and I know that that will help me find this unknown factor here. So notice we took that unknown box, we tried to just do the reciprocal. That didn't work. So then we had to do the reciprocal times the original product. 4/3 times 5/12 is going to be what helps us to find this unknown factor. So therefore, 5/12 divided by 3/4 is the same as 5/12 times 4/3. We get the same answer. So again, you're just rehearsing what's difficult for students. So looking at finding the reciprocal or rewriting it, we don't want students just to rewrite this as keep, change, flip. We're trying to, in the quick practice, go through the steps as to why that works, so they see it over and over and over again, because then they will generalize and internalize that particular formula or method. But we want them to first see why we're doing that. We don't just get to do the reciprocal. We have to go through these steps in order to see that really that got us to the same result that we were originally looking for. So now let's try it one more time. Read it with me. 5/9 divided by 2/3 equals unknown factor, which is the same as 5/9 equals 2/3 times unknown factor. Product, factor, factor. Product, factor, factor. We're looking for the unknown factor. What does the unknown factor have to be? Class, the unknown factor has to be the reciprocal times the product. Why? Because 2/3 times its reciprocal equals 1. And 1 times 5/9 equals 5/9. Now we have a balanced equation. We can take this original unknown factor and rewrite it. 5/9 divided by 2/3 is really the same as taking the reciprocal and multiplying by 5/9.